going to review scientific notation. To start, let's look at these numbers. So essentially, scientific notation takes out the extra zeros and shortens the number. It can be used, as you can see here, for numbers that are very large, or this one, numbers that are very small. So the first step in scientific notation is to find all the non-zero numbers, and after the first non-zero numbers, so let's look at this first one here. These are all not zeros. So I'm going to put a decimal point after the first one and write the other non-zero numbers behind it. So that's step one. I'm sure most of you have been exposed to scientific notation at some point, and you recall that it has the times 10 to the. So that would be the next part of the number, times 10 to the. So then what you do is you look at where, so here's where I added my decimal point. So you look at how many jumps it takes to get back to the end of the number. So 1, 2, 3, 4, 5, 6. So it took 6 jumps. So I'm going to put 6 up here as my exponent. Now, there's a very simple rule, and this is how I teach it. I don't do the left or the right stuff that you might have been taught in the past. I simply say if the number is greater than 1, you're going to have a positive exponent. If the number is less than 1, you're going to have a negative exponent. Sorry, I wrote that wrong. Okay, very simple. I like it like that. So because this number is way bigger than 1, I'm going to leave my exponent as a positive 6. Okay, let me show you with some more examples. On the next number, these are my non-zero numbers right here, but you can see there's a 0 in the middle. Doesn't matter, the 0 comes with it. So after my first non-zero number, I put a decimal point and I write 5.607. Now, again, as we just did, we write times 10 to the, and then we're going to count how many jumps it takes to get back to the end of the number. 1, 2, 3, 4, 5, 6, 7, 8, 9 jumps. So as you can see, this number is much bigger than 1, so we're going to leave my exponent positive. Now you can see down here on this number, I purposely gave you 1 where it's less than 1. So this number, we're going to have a negative exponent. So again, I just underlined all the non-zero numbers. So I'm going to look at this first one here and put a decimal point right behind it. And so I'm going to write 4.503 times 10 to the something. And I'm going to count how many jumps it takes to get back to the original decimal point. 1, 2, 3, 4, 5, 6, 7. So because it took 7 jumps, it's going to be a 7. And because this number is less than 1, we're going to make it a negative 7. And there you go. That's simple. Okay? No left, right. If you keep it to this, if it's less than 1, it's negative. If it's greater than 1, it's positive. It's so much easier. Okay? Let's try some more examples that were in the notes. All right. Now, the first number, again, is greater than 1. So because it's greater than 1, it's going to be a positive exponent. The second one is less than 1. It's going to be a negative exponent. So again, I'm going to find my non-zero numbers. So all I have is a 3 and a 4 in this one. So I'm going to put a decimal behind the 3 and just write 3.4. And then I'm going to do times 10 to the, and again, I'm going to count how many jumps. 3, 6, 9. It took 9 jumps. So again, because it is greater than 1, I leave my exponent positive. Let's look at the second one. You can see I have a bunch of non-zero numbers, and I have zeros in the middle. Because the zeros are in the middle, they have to go along with it. So again, I'm going to put the decimal behind the first one. So I'm going to write 3.0405. It's okay that I'm writing that much. It's just how this number worked out. And then I do times 10, and I'm going to count how many jumps it takes to go back to the original decimal point. 1, 2, 3, 4. Again, because this number is less than 1, it'll be a negative exponent. All right, let's go to another example that was given. These are in the notes also, but let's work through these. Okay, the first one. This number is greater than 1. I'm going to have a positive exponent. Here are my non-zero numbers. So I do 6.45 times 10 to the, let's see, 1, 2, 3, 4, 5, 6. So a positive 6. Second one. This one is less than 1. And here are my non-zero numbers. Put the decimal behind the first. So I write 4.56 times 10 to the. This one will be a negative exponent because the number is less than 1. So I go 1, 2, 3, 4. So it'll be a negative 4. Now, I definitely need you to be able to do like these two examples. Take a long number, put it in scientific notation. But also, you have to be able to see scientific notation and be able to know what it means, like be able to write it out the long way. So, in this one, we're going to write a 911, but because we have a negative exponent, it's going to be a very small number. So we're going to have a decimal with a bunch of zeros. Now, how many zeros is the question? So, I'm going to write 911 over here because that would be the end of the number. And again, remember, the decimal point's there, not really anymore, but we're going to do 7 jumps over. So 1, this would be 1 jump. Then I need, does it make sense to say I need 6 more zeros? Because that'd be 6 jumps. So that's what the number looks like written out long. Now, I'm sure you're asking yourself right now, do I need this 0 in front of the decimal point? And the answer is no. I do that out of habit because that's how lots of numbers are written in science. We'll talk about sig figs later and you'll understand that number, but I don't care if you put that 0 there. All right, let's look at the next one. This one has a positive exponent, which means we're going to make the number bigger with zeros behind it. So I'm going to write the 6, 2, 3, and then I got to do 4 jumps. So if the decimal was here, I'm going to do 1, 2, and I need 4 jumps. That means I need 2 more zeros behind it. So the final number is 62,300. All right, now let's do some examples that were not in the notes to see what you understand. Okay, so in this example here, you can see that the number is less than 1. And here are my non-zero numbers. So again, I'm going to write 3.21. Now, because it's less than 1, we're going to have a negative exponent. So we count how many jumps. It's simply 1, 2. So it's only to the negative 2. There is such thing as a negative 1. There is even such thing as 10 to the 0, which is the same number, which is silly. I've never seen it written like that. But you definitely will see numbers written like this with times 10 to the negative 2. The next number is greater than 1, we're going to have a positive exponent. So again, here are my non-zero numbers. I'm going to put the decimal here, so we have 7.23. Now, how many jumps over? 1, 2, 3. So because it's greater than 1, we keep it at a positive 3. All right, same with the next one. It's a positive, oh, actually, never mind, scratch that. This one, we're writing it in long form. Again, it's a positive exponent, which means that we're going to make the number bigger. Now it's only 2 jumps. So again, I write 6.44. But again, if I jump that decimal over 2 spots, I simply get 644. I hope that one makes sense. Finally, on the last one, this is a negative exponent, which means we're going to make the number smaller, make it a decimal number. So I write the 2 and the 9. Now, if the decimal was here, I'd make 1 jump over, the number simply becomes 0.29, and that's it. So hopefully this helps you. There's only 1 page in your packet that has scientific notation because it is something you have seen before and practiced before, but this is a refresher course. Again, I don't teach the going left, going right because I've heard different things. I've heard kids mix it up. So I just simply do, again, if it's greater than 1, you use a positive exponent. If it's less than 1, you use a negative exponent. And it keeps it much, much easier. You will see scientific notation all the time. You will have to put it in your calculator, which I'll show you. You'll use it in physics. So essentially you have to know this basic skill. All right, thanks.